Gareth, can you see that first screen?
Certainly do.
Okay, thank you, Gareth. Welcome to this NJMon and nmon user group meeting, whatever you wanted to call this. We have the virtual user groups. There's two of them running. They run a session once a month typically, and they have a whole hour or 90 minutes on a particular subject in great detail. But these are meant to be smaller, snappier, once a meeting on one topic. And we finished an hour and a half ago one for AIX, and this one's for my block tool nmon and NJMon. So we get stuck in here. I've been performance monitoring via my benchmarking heritage for all my time at IBM, 27 years, and 10 years before that as well. So I was like thinking about these things, getting the best from our computers. How can we monitor and improve the performance of our machines and now our virtual machines? On this slide, the first one, we've got contact information in here. If you want to talk to me just about nmon and NJMon, then you should use my Hotmail account if it's nothing to do with IBM. If you've ever bought a computer, then you're welcome to contact me on my IBM ID. So we're going to have the idea is now we're talking to hands-on people, not people that are more sort of architects and want to know about solution design and that sort of thing. We're looking at performance monitoring with my tools, particularly using open source tools. And we're going to have in future events various sections, as you can see there on the right. Recent updates, frequently asked questions. This would be more of a general introduction to NJMon. At the top, we have the URL. This is the web page we're going to use on IBM support, where you can find the slides and the recordings and find out what's in the next month's topics. Once I know. Now, my claim to fame is I invented something called nmon. This was used for benchmarking. I was doing lots of benchmarking, and we had lots of various commands that output stuff down the screen, but it's very painful to watch that as it goes up and down the screen. And so we consolidated all that information into nmon on a screen. And most of the hard work was what exactly do we want to monitor and how do we squeeze it onto the screen? And you can change what you're looking at as you go to match up what the memory and the CPU is balancing, what the disks are up to, and that sort of thing. Then we found out with benchmarking, you've got to have 6 graphs in a benchmark report, otherwise you don't look professional. And we also found out that we have 6 graphs and they're all different units and resources in the graph. Most managers don't actually read the report. They say, oh, this looks very thorough, and then go straight to the summary in which you say, this computer easily handles this workload and more, and we get a nice sale for an IBM computer. Later on, we first did that with Lotus 123, and then Excel became available and popular. So the nmon analyzer was changed to Excel, and later on, Excel doesn't like very big data sets, so we use something called nmon chart, which is a shell script that generates a web page with lots of little buttons on here to change between the graphs. And we've got some samples of them. Very proud of some of these graphs. This is what I call an iceberg diagram. So we've got reading networks at the top and writing to your network at the bottom, and you can get a balance of it. And these are bubble charts about which processors are using most CPU and has the most memory and doing the I/O all in one chart. Now, we finished nmon quite a long time ago. Things haven't changed very much. We haven't changed the paradigm for the way our computers work. The number of CPUs has gone up, so that we have to cater with that sometimes. The amount of memory's gone up, but that just changes the number and make sure we've got enough columns in here to put the numbers in. It doesn't actually require a lot of changes. So I got to thinking, since this was done and we were having to address the problems we were looking at the time, then things have changed. And if you look at, we started off on 1 CPU. Now we can have 192 with SMT, that's 8,000 logical CPUs. So we've got 200,000 times faster with the gigahertz we now run at. RAM has gone up by a factor of millions, so we were talking about kilobytes, and now we're talking terabytes. The networks haven't improved quite so much, but 10,000 times the rate. That's actually changed, had an epiphany earlier this year when I suddenly decided I don't need to be very efficient on the network because everybody's browser is terrible and it still works. I don't have to. I can have the luxury of doing things flexibly on the network as well. Also, the disks have changed. Of course, now we got solid state drives very fast compared to brown spinning disks, and now we have NVMe's. We can actually talk to the SSDs at much higher speed. So they got larger and larger and larger, but now we sort of started again with SSDs, and they're so much faster. We don't have to worry so much. Now, in those good old days, we had spreadsheets, Excel, and they can accept comma separated values files, and that's how we generated the nmon data, saved it to a local disk, just appending to a file. We could not have written across the network because the CPU effort and clogging up the network, the cards running the network would actually slow down our benchmarks. So we would have to do something very efficient with our data. Of course, over the years, people used to have one big computer running 50 different workloads, applications, and databases. Now we've broken everything up into virtual machines, and now we're going to containers, which is even worse. We end up with tens of thousands of containers, and I can't help thinking we're giving ourselves a management problem that we thought we got rid of years ago. But anyway, if we've got lots of machines and each one is generating an nmon file, you end up with maybe 1,000 nmon files a day to try and graph, and that becoming a real problem in data management terms. So what do we actually want to change from the old school to the new school? Then we don't really want my quirky SVC format. Sometimes we had to do really odd things in the spreadsheet format because things like Excel can't have 5,000 columns in a spreadsheet. So we want to move towards a standard format rather than comma separated values, and you can't change comma separated values on the fly. If you bring in another 50 disks, well, we don't know what to do with the extra disks in a column separated value format because we output a header line at the top when we started. We're giving the names of the disks, but now we got 50 more. How can we add that in? With nmon, very cautious about the data we get. Now we say, look, let's get every single stat. Some are obviously very important, but we may later on decide this is actually a particularly important new number for our application. And then we want to say, and what was happening with that number for the past year, for example. So we'll collect them even if we're not using them now because they may be useful in the future. And collecting a few extra stats doesn't cost us anything in CPU terms. We're going to centrally collect that data together over the network. There's new languages which are very good at data manipulation and plowing through large volumes of data and pulling out the data you want to do, perhaps graphing or downloadable tools. And then we got some new tools for all our data handling, sort of a databasing them rather than having hundreds of raw data files. And then there's some very clever new tools that do online graphing as we go. So these are the things that we wanted to add to nmon, and that means a total restart of nmon. We couldn't bolt that into the old nmon code. So if we go here, the industry standard is JSON. Very flexible, nice way of writing things. And if we get more disks, we have the names of the disks in with the data. That's not very efficient, but we don't have to worry about that with the speed of our new computers. It really gives us the flexibility of adding new stats at any time. That will arrive at our new databases and it will just be inserted straight into the database as new data. So yes, we will get every possible stat. Yes, we'll capture these all centrally, so we're not having to move files around. We can set them up and leave them, knowing that the data will be saved for us. The data handling, particularly if you've got JSON, we have Python. Python will read JSON in a very high speed. First attempt for me was 60 megabytes a second, and if I tried harder, I could probably go faster. But then Python has a natural data type, which it's called a dictionary, but it is basically JSON format. So it's very quick to load it into a native data type. Then you have an array of these objects, which are all the snapshotted data. And then we can go round a loop very quickly, pulling out the CPU. utilization numbers out of each record and doing what we want with it. On the data handling, I'm particularly focused on InfluxDB. There are other tools available, and for the graphing, I like Grafana. Both of these people have highly recommended to me. They're very, very quick to get going. There are some other tools that you may want to use, but we try to allow those too. Now, for your training into NJMon and using InfluxDB and Grafana, then I've actually created these 10 videos now. Up to the end of June, we had 11,000 views of these videos, so we're making some mileage in here. It's about 2 hours and 20 minutes training, and you'll nearly know as much as me by the time you get to it. It explains everything. I show you how to do the installs, what's going on. And in the past 6 months, we've actually made things simpler. We now have something called nmon as a variation of NJMon, and that allows you to, the install makes it a lot easier to do. This is my one chart that shows you everything. So we have data collecting from AIX, called the VIO server, virtual IO servers on our power machines. That is a copy of AIX, but it's virtualizing your network and your disks. Fortunately, the way we collect the data in AIX is also available on the VIO server to collect all that data. So we can get both of those very easily from something called the libperfstat library in AIX. We can also, because I'm running the nmon for Linux, I know how to get all the important data out of Linux. So I brought that into the folder as well. So we can do Linux on power, but we can also do Linux on those ghastly, what are they called? Intel and AMD processors. It works just as well on that, or Raspberry Pis or whatever you're running out there. So we run our daemons on each of our endpoints in here, our virtual machines and machines. We pump over the network all the data into the Influx database. The Grafana is the graphing engine. We name our Influx database as a data source. It then connects to it and says, yes, I can understand all this data in here. And then it generates the graphs that we actually see in a browser window. So with a browser window, we connect to Grafana and we can see all the graphs there. And down in here, I've got a list of all the graphs that, or the data we're currently getting. There's probably a few missing in here. Some things we've added in the past year with GPFS, or spectrum scale as it's now called. That's nice. That's not very easy to get performance data out of spectrum scale, but we hook into their tools and scrape the data out of that. The VIO server stats in here, including the shared storage pool, a piece of technology that I particularly like. If you're running AC922s or IC922s, then we have NVIDIA GPUs in there, and we can pull out the stats off the GPUs. So it's got things like temperature, the electrical power supply, and the utilization of the CPU and memory comes out of that. One we recently added is the RPERF values. That can be useful when we're trying to scale up our machines. If we move from a Power 7 to a Power 9 machine, how many CPUs does it need on the much more powerful Power 9? Or we can calculate that with the RPERF numbers. Or if you're doing server consolidation, it's a quick way of getting those numbers out for you. And it's all down in here. tinyurl.njmon is the website where you can download all the code, and there's lots of pictures and suggestions and details about how to get these things going, and the latest versions are put out on that. Okay. By the way, this thing called InfluxDB and its alternatives are called a time series database. Brilliant bit of technology. There's very few things I look at and I think, I wish I invented that one, because that is really smart piece of technology. Right, let's move on. And it didn't move. Let's try again. Okay, so InfluxDB, this is a chart about it. There are the alternatives we'll come to in a minute. Fairly small company. I've been to 2 of their conferences, one a physical, actually went there, and one a virtual in June, and learned a lot from these guys. So the first one I went to, in their first session, they had like a 101. This is what you really need to know about InfluxDB. And they covered 3 things. I went, oh, dear, I didn't notice that one. I've got to go back and change all my code. And I can really get the benefit of this brilliant piece of technology. I hadn't been using the tags very well. in time series databases, things like the your CPU and utilizations, that's fine. But there's some resources like disks, where you have lots of disks. And what you really want to do is, different virtual machines will have different numbers of disks, and you want the graphing engine to look in the data and say, okay, you want the disks, but there's 10 on this virtual machine, and there's 100 on this virtual machine, and it be able to discover how many disks there are and draw the appropriate graphs with the appropriate number of lines on each of the graphs. And that's what the tags are actually used for. So we put that in, and they boast high-speed ingestion of your data, 1 million measures a second, and they tend to point out the fact that some of the competition can't meet anything like that. But they are fast in intaking data, better than perhaps than a relational database that's got all this SQL stuff and indexes to update. It's all doing it internally to itself. And you actually see that IBM is a user of the InfluxDB. We use it internally, and we use it with some of our clients. Grafana, this is the graphics guys. I've just got a picture of some of the graphs in here. Very nice graphs. About once a quarter, they come out with a new small number version. And the important thing is to go to their website, which is grafana.com, and they've got what's new in version 7.04. And they usually got a few new graphs and new beautiful colors. And you think, whoa, I'm going to put some of these into my NMon data. And hopefully make use of some of those the new features in here. I've tried to keep up to date. Now then, okay, this is a complicated chart in here. Up the top left, we've got NJMon for AIX and Linux in the VO server, of course. This produces JSON data. That's what the J is for here. And so it sends it to a central machine that's running this daemon, the NJMon daemon. .py, it's actually written in Python, which is a very nice way of writing multi-threaded applications, and it can save the incoming JSON data into a file. We can use that later if we want to, or in other tools, or it can join onto the Influx database using a Python library as a client class. So it includes that into the code, and then it's got a functional interface to actually load the data into InfluxDB. And as I said before, Grafana is doing the graphing engine, and it just sees InfluxD as one of its data sources. Grafana can handle, I think it's over 30 different sources of information, and you can see them here. Some of them. Splunk is one of them. This is a well-known closed source provider for collecting information. They tend to come from taking all your log files. You have to describe the fields in the log file, and then it puts the data into the database, and then Grafana can take it as a data source and read through the schema, if you like, of the CPUs and memories and disks and things, and then get the actual stats out to graph. A similar thing happens with Elastic in here. If you take the JSON file, Elastic, they're also known as Elasticsearch or the ELK stack. They have something called Beats. This is an open source product called FileBeats, which you have this for AIX as well. But you effectively tell Beats that you want it to monitor this particular file or this directory full of files, and it effectively looks at the end a little bit like the tail -F command, and now and again it looks at the file. Is the file bigger? And if it says yes, then it grabs all the records at the end and pushes that into Elastic for you to explore later on. And to get that to work, the Elastic people wanted the JSON to be in a slightly different way. For InfluxDB and Splunk, we have different measures, but if you go into one of the disks or the networks that has multiple resources, they like to have an array in here rather than a number of JSON records. So we have a -E option to fit in with them, and they say that makes it much easier for Elastic to ingest the data, so that was easy to do. Then we're having people having some real success with NJMon, and then I decided having this thing in the middle in here makes life complicated. It's an extra thing to set up. You have to then connect to InfluxDB at one end, and it's running as sort of a website taking the files from the NJMons on each of the endpoints. It could go a different way. We could convert from outputting JSON to outputting something called line protocol. This is a fairly crude protocol. It's line by line, and effectively what's in a JSON record, which has like names and values, all of that goes into one long line, and it goes into InfluxDB. But it is sufficiently close that I could write a different back end for NJMon to output a different format called line protocol. And then instead of connecting to NJMon-D, it actually connects straight through to InfluxDB. Now we don't have any JSON in here. The I in here is for the inline, straight to InfluxDB. So we can't save it to JSON. We can't send it anywhere else. There are some other tools that can understand InfluxDB line protocol, but it goes straight in there, so we don't need that intermediary in the middle, which makes it much easier to install. It may even be a little bit faster as well. That worked quite well. Well, it took me quite a long time to work out how to get the line protocol to work. The basics is well covered, but the specifics are quite difficult to work out. Then we found that we were missing one of the other big ones. So we got Influx, Splunk, Elastic. They're the big three. And the other big one was Prometheus. Now that's quite important, even for IBM. If you're running Red Hat OpenShift, then you're running containers and Kubernetes, and their default data collector is Prometheus. Now, Prometheus is a bit lightweight. By default, it will throw the data away after 2 months because containers are coming and going on sub-second level of start them up and throw them away. So they don't keep them for the data for long term, but it allows you to see what's going on now. Prometheus is completely different the way it gets the data into the database than all the others put together. Prometheus, all the others are standing there and you send the data to the database. Prometheus does the other way. It goes to the endpoint and pulls the data to itself. So you got nmon trying to output the data when it's ready, and Prometheus is trying to grab the data when it's ready, and that was never going to work. But then we realized there's a thing called Telegraph. Now, Telegraph is written and supported by the InfluxDB guys. And it allows you to have lots of different format coming in one side and lots of different formats going in the other. It's like a telegraph or telephone exchange sort of stuff. But whatever's coming in and out you want, any pairing of those two, and it worked fine. And it turns out to be the config file is like 8 lines or something to get this to work. So you start up Telegraph, it pretends to be InfluxDB, so it accepts the line protocol data coming in one end, it saves it, and then when Prometheus comes around to say, give me the data, it gives the last set of data to Prometheus, so it's happy doing the pull operation on Telegraph. And whoa, that took a whole load of horrible coding and testing it straight out the window. It was all done for us. Now, when you're talking line protocol here, you have to include the specifics on how to log into the InfluxDB, but we haven't got InfluxDB in here. So we added an extra little option. Don't send the login details to Telegraph because he doesn't care. He's just saving whatever you give him, and he passes it on to Prometheus without understanding who you are. Are you allowed to send me the data? So we have all of these are now supported in NJMon and nimon, and that tends to be the way I say it. And then we get the data coming out at the other end, so we can get some nice, beautiful graphs and config information as well. Right, now, if you're trying to sell NJMon to use, I should point out something. This came up with a conference call a week ago. NJMon, let's go back one page. Whether you come in as an NJMon and save the data into InfluxDB, or if you come in with nimon and save the data in InfluxDB, it's the same data. It can go into the same database on InfluxDB, and Grafana will see it as one data source. It will intermix the actual data content. The names of the stats and the numbers are all at the same set. Okay, so this, although they look terribly different, they are actually all putting the same data to the same database. So if you're trying to sell, why would you want to do this? All you have to do really is show them Grafana and the user experience and say it's all free. NJMon is open source. It's on SourceForge. The InfluxDB and Grafana are open source. And I didn't actually cover it when I looked at both of those. InfluxDB and Grafana have an open source version, and they can pre-compile it for you to download and use and do whatever you like with it. They also have an enterprise version that has some extra features, particularly in the HA, high availability, and backing up and things of that area. So some extra features for large scale, and of course you get 100% full support for them. And if you don't want to bother with your own hardware and set up your own disks and managing all that, you can just buy into their cloud service. InfluxDB and Grafana offer that. So that's all handled over here. And why are we doing this for IBM? Well, we like to have AIX and VO Server joining in with all these latest whiz-bang open source tooling. And if we have customers that are happily seeing the good performance on the machines, they're happy customers, they come back to buy more power and AIX and Linux on power. And we can also use it for upgrading because we can see how busy their older machines are and recommend newer machines for Power 9, server consolidation, that sort of thing. So I'm going to break out of this and I'm going to go over here. One little thing, it will come up on a later chart. Well, let's go over it now. There's some really good guys in here called Power DevOps. I've met them at a technical university. And really great guys, because what they do is take open source software and compile it to run it on Linux on Power. If you look over here, monitor, you look for InfluxDB. This is the little website in here, and you can see they have the latest version of InfluxDB. If a new one comes out, it usually takes them like a week or two to catch up. But we have Red Hat Linux Enterprise 8 and 7 and SUSE 15, and then Ubuntu in this case over here, and this is a slightly older version for AIX 7.2. Now, if you want to do it the easy way, this is what I'm doing here, Red Hat Enterprise Linux. The AIX one might be slightly different because you find, that's a tar file, so you may have to go putting things in the right place. Where if you look at these ones up in here, it's an RPM, it'll put all the files directly into the right place in the file system. And come back at the top, monitor in Grafana, and it's a similar sort of deal in here. The very latest, this is literally 3 or 4 days old. Red Hat Enterprise Linux 8.7, we've got SUSE 15, and this is a slightly older version. We haven't got an AIX version of Grafana. Now, funny enough, if you're not working as a big group, you're just trying to a profile, prototype or something, you can actually run Grafana on your workstation if it's if it's Apple OS, Windows 10 or Linux on your laptop workstation. You can actually run Grafana on that and connect to your InfluxDB, perhaps in your database. You don't really want to run InfluxDB on your workstation, because whenever you power your workstation down to go into the office or change building, you're not collecting data, so there'll be big gaps in your data. Right, now, back to the main plot. This is an example. This is what I call my Simple 6. This is a good starter pack. This is Grafana up in here, and hover down here. This is 704. And this is, you've got CPU, run queue, network in here, disk busy, file system space. You can see it going up and down a little bit in here, and memory. And this is the user interface. But let's quickly tell you, a few of the highlights in here. Up and this is the range of the timestamp. So we can say, give me the last 6 hours, and it will redraw the graphs. So not much going on in there. Go back up here, the last 90 days, perhaps. Because this is where all your demos go horribly wrong. No, it's catching up. Yeah, I truncated my data to keep the volume down a bit in here. Or you can say, okay, that looks like a busy period in here. So I zoomed in. In here, I got the consumed, which this is number. If I hover over it, you can see the yellow number is in bold. 3/100th of a CPU. The one up here is my entitlement, and this is the virtual CPU number. I've set this up with variables. So this variable in here is the various machines that I'm running NJMon on. If I change to the Silver 6 machine, you can see I've got some artificial workloads running on here. So this is getting busy every day. And again, I can zoom in and see some details of, what happened there? That's an unusual one. And actually find the peak and drill in and find more information. But this is just one template with a few graphs on. You can have lots of templates with your favorite graphs on, and we can flip between our machines. But that isn't really the main power of Grafana, because all you have to do is go up in here, add a panel, and I can dynamically size it. So I can say, all of these are dynamically configurable, move them around to what I want. So in here, it says, okay, I want to add some more data. This actually generates some random data in here, so don't get too excited about it, just to show you that it's working. I'm going to collect on here. These are my data sources. Actually, monitor the temperature in my computer room with here. Here's the Prometheus where I was testing it earlier. So here's my NJMon database. Then down in here it says select a measure, and I want to look at the CPU. I just started typing in util information in here. Actually, no, let's try. Just trying to think of a good example. This is my kernel data. If I then look down the values, there's a whole bunch of stuff in there. In here, I want to look at, somewhere in here. Oh, it's run queues down here. It's good. And we've got some graphs coming in here. Let's look at the last 24 hours, and we've got a graph. That's it. We're done here. Is it panel data? We could put in here run queue. You can just quickly graph anything you want. These are the different sorts of graph we can put in here, heat maps and pie charts and things. They only work if everything always adds up to like 100%. Memory would be a good example of that. And we've been using these carpet plots recently. Here it says kernel mean because it's doing the mean of the run queue, but I could put in here run queue, and then if I wanted to collect some other stat on top of this, then I can just hit query and it will let me do that down in here. But you're getting the idea, and I'll just apply that. I've got my new graph, whatever it was, as long as I can find it by drilling down into my data. We can do that, and then you might say, well, run queue isn't green, is it? Run queue is red. There we go, and we hover over here and hit E. We're back into edit mode, and we can do all sorts of things down here. We'll switch the lines off, nothing happens. We've got bar charts. If we drill in, actually, you find this is sort of philosophy going in here. These are the measurements we've been taking in here, and it's not quite sure what happens in between. So it says, well, I don't know. What shall I do? So at the moment, if it doesn't know there's a value there, then it just puts in a null, so it looks like 0. We can go in here and say, connect up your points. I didn't do it. That's the bar charts, right? Switch off bars and go for lines. Switch off connected again. Yeah, we've got nulls in here, and then we can say connect them all up, and we can do all sorts of them here. We could have points as well. That's good because you can actually see how often you're collecting the data in between. You can say, no, I want nice big points. There we are. My eyesight, so I want really thick lines. Whatever you want in here, colors and all sorts of things can be changed in here. And we can, sometimes, if all the data is between 3 and 4, then it will stretch that out. But sometimes you want the 0, so you can set those in the axes down in here, and a whole bunch of other things you can put in here as well. But I hope you see the flexibility in here. And just because I've saved a template, these templates are actually available on Grafana. You go to Grafana and find the template number, and then you come back in here and say import template 5,000,003, and then bang, you got all the data on my set of graphs. And you can collect your own set and share those with people as well, looking for these names. This is a simple one to get you going, make sure it's basically working. There's more complicated ones in here. So I've got a whole lot of configuration information in here about all the things we can set in Power VM. We can see the megahertz. In these cases, these are what's called a single stat, and it's showing you the last value that it came out, because it might be going up and down, but this is the last one, most current. So this is the gigahertz running at 3.941 gigahertz. we're overclocking. Well, we're not meant to use that word, but 19%, and you can see the name of the L bar in here, and it's running 7.2 TL4. And like I said before, we can quickly change that TL. What do we got in here? This is AX6 running in here, and it's peaking quite heavily, quite a lot. That's last 30 days. Okay, we can down to 2 days worth, and it will draw the graphs. So you can start to see the power of this thing. It's up for you to decide what you want to draw, rather than me give you a master template. It might be perfect for my benchmark, but it may not be applicable to what you want to do. We can also, this is selecting on a particular LPAR, and in here, just checking my times, and I'll have a quick drink. Hold on a second. This is the serial number of my Power 9 machine. It doesn't look very specific there, but that's what we got. And we've got the all the LPARs in here. These are my LPAR names in here, and this is not stacked, but this is stacked. So you can see out of my 16 CPUs I've got, we're using 3.5 during between 8 and 9 and 10 o'clock in the morning. You can see what the machine's actually doing in here. We've got the memory actually in use stacked, so we're using 10 megabytes of memory, and we can see in here I'm not doing very much disk I/O or network I/O in here. Break that apart a bit. Doing something was going on in this period of time. I can hover over here, and it's 3:38. This is probably my backup running on my machine in the middle of the night. It's good to know. But again, we can bring in any other graphs you'd like in this sort of mode, and it's working out how many machines you got on this particular serial number. And so if you moved an LPAR from this machine to another machine, then its graph would suddenly stop, as there's no data available for it as you go forward. Now, once you get a time series database, you suddenly think, hang on, there's a lot of information this would be really good for. If you've got an application, perhaps there's a database running, and you can say how many transactions a second we're doing, how many of those are working, hopefully nearly all of them, but some of them might be failing, for example, if the front end's crashed because the user disappeared or something. And whatever the application is, the interactions per minute per user and things, any sort of stats you can get, you can put them into the same database and draw your users logged in compared to your CPU use. And you might well find your Dolly Parton curve of peaking the workload in the morning, in the afternoon, and nothing happens at night. I actually am monitoring the temperature in my computer room in IBM South Bank. Unfortunately, we've suffered from quite a few air conditioning failures in a computer room, and we actually use this tool to say, whoa, the temperature excursion, we call it. And the bottom one in here is the temperature underneath the floor, and you can see it slowly rises as the aircon fails. And our computer room got quite hot, and our computers got even hotter. They got to 38 degrees centigrade. Now, that is actually the temperature coming out. As long as the temperature going in is nice and cool, we're okay. So the room temperature was 29, which is still within our ASHRAE envelope for computer rooms that the power computers are built to. So we're okay. Not going to destroy our computers to get them overheat. They'll actually protect themselves and switch themselves off if it gets too hot. But one of the times we were getting our storage pretty hot, and we were actually getting a couple of failures on these very old B7000s. And we got, okay, I covered most of those other things. Right. So let's go back to a presentation and carry on. Oh, no. Okay. I just copied in a few graphs. There's all sorts. So there's like rev counters, if you like. Porsche cars with lots of rev counters in that. They can be quite nice. You can see this is clear. This is quite cleverly done. I presume it's a stacked chart, and they've just coloured them all various shades of blue. So you get these sort of Blue Ridge Mountain effect going across there. I don't know. You can, some artists can do some very beautiful looking graphs. Now you might be saying, well, this is all very well. It looks pretty good, but I'm not sure if we really want to do this, because you're thinking it's going to look a lot really hard to do. So I've got this one chart that tells you everything you need to do to get this running. I'm assuming you've got some hardware. It could be a laptop. I mean, I've run it for like 10 users on a Raspberry Pi in one of our conferences. So it's fairly lightweight as long as you don't push too much data into your database. A laptop will do a handful of users for a month's worth of data, no problem at all. We have some pretty old Intel boxes that we started off in, and now I'm using it on Linux on Power to actually run it because that's what I'm used to, what I've got plenty of spare resources for. Up in here, so we've got a fresh OS for, this is the Intel land, AMD 64. Of course, I like to highlight the fact that AMD invented 64-bit Intel computers. Just to wind up the Intel guys. And you can get the downloads from Influx or Grafana. It's not download, it's called Get, but there we are. And these are some of the flavors in here. There's some other operating systems as well. If you're on Power, then you get it from DevOps, and I'd recommend one of these 3 Linux variations. Only try AIX after you've got it successfully working on Linux, so that you're not trying to do 2 really hard things at the same time. And these are our PMs. So you just run them and they install. The download takes 10 seconds, so that you're nearly into 3 minutes worth of work after the OS is installed. Switch off your firewalls because you don't want to muck about with that. And then you go to Influx. This is the command line for Influx. You create a database. Here's the name of the database and exit. And that's done. InfluxDB is set up and ready to go at that point. The login, you log into the Grafana website at port 3000 by default. You can change that if you want. You click on the add database source. You say it's InfluxDB out of a list of 30. And then you give it the name and you say accept, and it says green, it's going to work. I've talked to him and we're talking the same language and we found some data already. Then you're going to have to go and put some data in the database. So you're going to run NJMon or nmon. nmon is the simpler one to get running. And so this says take a snapshot every 30 seconds. We tend to run this at a cron tab, say once an hour, and the -k says if you found that nmon is still running, just quietly stop. If it found it crashed, then it starts a new one up for you. This is the IP address or host name of where Influx is running, and this is the port for Influx database itself. And then you've got to give it which database you want the data to go in, the username and password. Okay. And then give it an hour if you want some data in there. Don't try and draw a graph with one data point on it. Then you can go to the Grafana website itself, on the internet, and you search for NJMon in the dashboard page. Search for dashboards that have got NJMon in them, work out the number, and then you go to your copy of Grafana running on your server, and you say import dashboard template and the number, and it will pull it down. It'll actually ask you, this template seems to have a particular data source. Which data source would you like? And that's the one you created up in here, NJMon. And then it will change the charts so the variables will point to that right place. And up you should come with your first probably simple 6 template. You can pull down more complicated ones later on. And of course, you really should fix your firewall for those 2 ports, and so that you're nice and secure. And the whole thing, I think if I practiced for a day, I could probably do the whole thing in 10 minutes flat. It's really easy. Some people have got lost when they're trying NJMon because they haven't quite got the pointing to the right port numbers and things like that. Or they're running NJMon and the numbers seem to be going, but they don't get there because they've a slight mismatch in the way they've set things up, or they forgot to start the NJMon daemon, for example. Anyway, there we go. I already mentioned the Power DevOps guys. She shows you the website. This is another sort of new simple graph they got. These are like single stat, but they'll actually draw a little bit of a graph in the background. So you can see, oh, this is going down. That's good. This is going up. Whoa, I want to check that one. What's it? Network traffic. Okay, it's going down again. That's okay. And you can get a lot of stats on one screen. And you do find a good size screen, or screen with lots of pixels, so it really does look good. and lets you see a lot of information at the same time. This is what I've just been doing for fun last week. This is called a carpet map, which is a heat map. I don't know where the word carpet comes from. Maybe it's because of the patterns you can see in more complicated data. But this is midnight, and this is 11 o'clock at night down in here. So this is 1 day per stripe. And then you select at the top, like the last 7 days or the last month. Then you can immediately see, look, oh, we were busy in Wednesday and Thursday last week at 2 o'clock and at 9 o'clock in the morning. So this is like the side-on view of Dolly Parton here. There's some blank in here because we've had problems. Oh, I was upgrading InfluxDB and Grafana one couple of days. I forgot to start them again, and they've got some more blanks in here because my Raspberry Pi that has the Temperature Pros decided to crash. We had disk issues in the Raspberry Pi. So with the lockdown, it took me a couple of days to get back in the office and fix the disk for the Raspberry Pi. But apart from that, you get nice quick pictures. You can say, how busy are we in the last month? Oh, look, here's the end of month processing coming up in here. This is the peak we have to watch, and then you can learn about your workloads very, very quickly and which periods or days of the month or quarter are the ones you really have to watch out for this particular machine. These grey points in here, actually, you can mark in any of the graphs. You can mark a particular point and make a note, if you like, next to it, annotation on the graphs, and we can do alerting as well. So you can say if the graph goes, 95% busy for the CPUs, then it will start sending off emails and things. One thing you notice about the carpet graph, some of it will be dark green because that's the lowest level it found, and some of it will be bright red. So this is the highest level. This doesn't actually mean a problem. It tells you how much work it was actually doing in the red periods, but the lowest would be some of both. Now you could set to go into the the configuration for this and say don't go red when it gets to 1.1 CPUs. Go red when it gets to 95% busy or something. Then you might find some of them are green, 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 and green, in which case it's got too many resources. You could harvest some of those and put them into another machine. So these are some questions that I've typically got quite a lot of. How are we doing? Just 50 minutes. Okay, well, I nearly there. This is time series databases. Once you've tried one, you can find all sorts of data that you want to put in one of these. Extremely fast, easy to use. They call it 5 minutes to awesome. Is their plan for their code. I have had customers that have got their database people to run InfluxDB because they thought DB stands for database. Well, it does, but it's not an SQL engine, and it has no personal data in it whatsoever, unless you think your computers are persons. So there's no point in having them all locking down and only using secure sockets and things like that, because there's nothing personal in here. The temperature in your computer room is hardly personal, and I hit the wrong button. Okay, let's carry on. Yes, there's some more comments in here. So I wanted to include this because it's got some graphs on it and some general stuff and one place to go. And some more in here, 10 minutes to get an install and get your first couple of graphs running. You can then use InfluxDB and NJMon to actually monitor your InfluxDB and Grafana machine to see if you need to add resources to handle your data loads. We've seen that one as before. I've got 2 pages in here of the recent highlights. This is what we did in December, and we just produced version 64 with a whole bunch of extra things in here. We produced the nmon. I told you about the Prometheus. We got a way of adding data to NJMon and nimon, and so you can add your own stats if you're a C coder. I'm working on another cunning plan that if you can get some numbers onto the command line, then you could run a command on your command line and send those off to the Influx database as well. We put the configurations for NJMon into actually a little small file. Otherwise, we found if you put them on the command line, one of them was the username and password, and anybody that logs in can see the username and password for InfluxDB, for example, which you don't really want to share. Okay, and that's it for today. That's a lot of information. I see 8 people. Gareth are still here. Well done. Normally we would try and have some time for comments and feedback. So thank you for your time today. What I want to know is that's an experiment. Is that worth repeating? And we can go into some more interesting questions and questions that you send me. We can get those answered as well. So please give me feedback either now. I'll stop the recording in a second, and you can ask questions or just send me some email on Twitter. Mr. NMon or LinkedIn is here. If you've got a particular thing you want to talk about as well, we'd maybe invite you as a speaker. The next session's 3rd of August. We'll try and do the first Wednesday of the month as a first stab. See if we have enough people to keep that running. Right. Oh, this is me thinking in my office at home. You probably didn't want to know this. This skull in here, that's the last person that asked me a really dumb question, by the way. Is it? I'll warn you about that now. How do I stop this thing? Oh, yeah, right. File sharing, stop. Okay. Switch off the recording, stop. 51 minutes, stop recording.